Welcome to Chapter 2. In this lesson, we're going to learn why you need surfaces. Believe it or not, I used surfaces to create this part. Now, I didn't create it all from surfaces, but there were some key features in here that had to use surfaces in order to be created efficiently. Let's take a look at why even machine design type parts like this one can benefit from surfacing. If we roll back the feature manager, the first feature that we see that uses a surface is an extrude. And if we see how that was used, it was used as a part of a cut to extrude up to the surface. So there are times when a hole, for example, may not have an end condition that can be created using standard cut features. And you may just have to cut up to a surface. And that type of thing works well in SOLIDWORKS. Now, another surface that was created here is a surface that goes around the part. And if we show this, what it's doing is it's actually creating fillets that go around the corners. When the cut is created using the surface to cut the solid, you can see the reason that you can't use regular fillets to create this particular geometry is because part of the fillet is cut off. In order to create this geometry with solids, you would have to have the extra material on the top, put the fillet on, and then cut away the extra material and create this undercut as well. So it was just a lot easier to switch this around and create the partial fillet with the surface feature. There are some other types of surface features further down the tree. Ruled surfaces, trimmed surfaces, offset surfaces, and several others. These went into creating some of the more complex geometry inside the part. This is a valve or a solenoid of some sort. If we hide this surface body that's in the way right now, we can see inside. And here, this is parted at this point in the rollback in the tree. A lot of this was created using surfaces. Not all surfaces are used for complex shapes. The surface features have regular features, just like solids. You can extrude, revolve, sweep, loft, and then get involved in some of the more advanced types of surfaces. Surface modeling is all multi-body modeling because every new surface that you create creates a separate body. In solids, each solid feature that you add generally merges the rest of the solid body. But you have to build your own when you're using surfaces. You can think of surfaces as manually building a solid. If we go back to a familiar example by now of the mouse, there is no single feature that you could use to create this shape using solids. So the way it was built was to build a couple surfaces at a time. In this case, these surfaces are just reference surfaces. The main part surface is created just one at a time because you couldn't get a solid feature to create all of these surfaces in a single feature. So in this part, several surfaces are actually faces of the finished model, such as these two, and some surfaces are just used as reference. 3D reference geometry is another great use for surfaces in SOLIDWORKS. They can be used to cut solids. They can be used with the replace face feature to simply replace individual faces of a solid model. You can use a surface also to remember a face in a previous state. Let's take a look at that sort of feature. In this case, I used an offset surface. Let's turn this on so we can see it. I wanted to remember what this surface looked like before the finger buttons were trimmed out. So the memory surface is yellow, and it allows me to access the entire smooth surface even after the finger holes have been cut out of it. So if I ever needed to extrude up to an entire surface, I've got the memory surface here to allow me to do that. And again, this is just an offset surface feature. Surfaces also can create a solid. So let's go back and hide the reference surfaces. And at this point, the knit feature allows us to create a solid from all of the surfaces. There's an option, try to form solid, so that if you have surfaces that fully enclose a volume with no gaps or overlaps, this can create a solid. With the solid in place, now we're able to use regular solid features on the solid created by surfaces. Another use for surfaces can come in the form of creating molds. So in this case, we started with a plastic part, basically a detergent scoop, and we created a parting line around that so that it can be molded. And from that parting line, we created a mold block and then this to split the mold block. So you can use surfaces to cut solids or to split solids. Another function that's commonly used is when importing parts. For example, if you imagine that this was an imported part, it comes in with 4 ribs. For some reason, we need to get rid of one of these ribs. If we didn't have all these SOLIDWORKS features, you might be stuck. Except that you can change this into a surface model, and the delete face feature can be used to remove all of the faces of the feature that you want to get rid of on an imported part. And then at this point, we have a surface model. Just to let you know, if we back that up one, it's a solid model that we're starting with, turns into a surface model because it now has a big gap in it. And using the delete hole, we can close up that hole in the surface model so that it can become a solid again. To create a solid from an enclosed surface, we use insert, face, thicken, and there's a special option that becomes available for an enclosed volume, and that's create solid from enclosed volume. Just check that, click OK, and now SOLIDWORKS has turned this back into a solid again. So surfacing can be used to make extensive changes to imported parts. In the rest of the lessons in this chapter, we will learn more about different surface types and different types of techniques that we can use to design parts that you need to design.